Hi everyone, welcome to ST Skills. Today, as part of system design, I picked up some patterns, some distributed patterns which help the problem of resiliency. So if you have not heard of this term, it's okay. It's just another buzzword for some category of patterns. And before we get into the topic, again, this is like volunteer based. If you want to learn and present some concept, you can always do that. And today I just wanted to show an example where oh, sorry, I think I'm hearing my voice echo back for some reason. Okay, it's fine now. So this is just a material on the Microsoft website, which I found very helpful for the design patterns. And there are various other patterns that you see. I just picked the one which I felt like is important to know for everyone. So there are many other categories if you want to pick and learn. And like even if you don't want to present, you can always go through yourself after this session if you want to like learn more about it. So the reason I resiliency is like this revolves around the failures that we see in distributed systems, and it's often very important to design for failures, design to handle failures. And like also like there is also another term for this, design for self-healing. So I think most of these patterns fall under the same thing, like design for self-healing or design for resiliency. um, just to understand this term better, as you can see, it's like resiliency is the ability of a system to gracefully handle and recover from failures. We know that like in distributed systems, no system can be like bulletproof or fail proof. So failures are always bound to happen, and we just need to have a way to deal with our for our system to gracefully handle and recover as quickly as possible. So, so with that, like let's see what are all the patterns that are listed here. So I'll give a quick summary, and we can jump into each of the patterns. So bulkhead, it's just like if you have multiple services in your application, you're just categorizing like into separate pools, so that like if one part of the application fails, the remaining parts of the application continue to be up and serve other tasks. And circuit breaker is actually there are like different kind of systems which different kind of failures, like some can work with just a retry and some can take variable amount, like they might be too busy, or it could be an intermittent issue. So this is one of the pattern which is efficient in handling, or like immediately like kind of fail fast rather than like probe the system. So it adopts that pattern. And this compensating transaction is similar to Saga in microservices. So it's like we know that like the systems, when we are not building for strong consistency, we will even adopt eventual consistency. Whenever you adopt eventual consistency and you have multiple parts of the system, like if you ever need to um, undo the changes of the previous steps, like if you have 10 steps and 4 5 steps are completed, like to undo the previous steps, like this is one other flow which you normally have. So that's about compensating transaction. And this health endpoint monitoring is again like as the name says, like you have the endpoints like in your all services that you offer, like you'll have some endpoints which will indicate the availability of your service, like it could be some uh, critical functionality or like non-critical functionality, or whether the database is up, or whatever the resources that you have are all functioning properly or not. And leader election, it's not like a straightforward, but is most systems have some form of a leader. So in other words, like you need like if you have some kind of tasks which are managed by multiple nodes, you often need one leader to coordinate the changes or merge the result of the all other uh, nodes that are performing that certain specific task. So this queue-based leveling is a pattern where you are sometimes like there could be times like where you get some peak traffic and sometimes like less traffic. So you generally don't have your systems to adapt to that peak load, like unless you have that on-demand scaling. So having a queue as an intermediate buffer, like even if you have peaks, like your services can always process the task based on their capacity. And there is like retry. So this is again like simplest one. Like most of the times the failures could be temporary. Like with a simple retry, it could succeed. So it's about that. And this is just a scheduler agent. I think I didn't have this in my agenda, but like it just coordinates the set of actions across distributed set of services. I think it may be similar to leader, but like let's see if we get time, we'll go. We can explore and see what this is. Any questions? Let me see if I have to mute someone in between. I'm hearing some disturbances. I'll mute everyone and then maybe you can unmute when necessary. Okay, and let's start with one of the simplest patterns like retry, and then we can we'll definitely go and cover all of the patterns. So as the name suggests, like retry is one of the simple techniques where like if the failure is like transient or like temporarily, I mean like it could be intermittent. So if you just retry, if you know that it's likely to succeed, then you use the retry pattern. So I'm still hearing some noise. I don't know where it is coming from. Okay. So the context, as I mean, like as I said, like, oops, why is that somebody is trying to mute themselves? Okay, so we know that like faults could include like you can it's like a momentary loss of the network connectivity, or temporarily the service is unavailable, or like there could be some timeouts like saying the service is busy. So we know that like if we retry, it's likely to be successful. That's where we use this pattern. And I think they are talking about the database service. Like if you have large number of concurrent requests and if it has a throttling, in those cases, I think you want to retry only after certain timeout, or like because it knows that service is already busy. So we will look at that. So how this there's always like scenarios where whenever application detects a failure, like for the first time, there could be three possible strategies. I mean, like three possible response that the consumer can take. So the first one is like cancel. Like if we know that if we retry this request, and if we know that it's unlikely to be successful, then we shouldn't retry that. So one of the example they have given here is like authentication failure. So so the credentials, whatever is given, like if it was like invalid, even if you retry, it's unlikely to succeed. So those kind of errors, you can immediately cancel the current request from the client and abort. So the second one is like if we know that the error returned by the service is unusual or rare. So it could be from network disruptions. So then, like you know that like if you retry, it may be successful. And there are like some kind of errors, like where the server might say it's too busy, like 429 or some other request. Then you know that like if you retry immediately, it's likely to be busy. You don't want to waste time like by immediately and overload the service again by trying immediately. So you use some delay, and then like after some seconds you again try the request and see if it succeeds or not. Generally we have like two or three retries before we return failure to the calling application. And similar to this retry, there is retry after delay. There is also like this delay can be like an exponential. So that will work only if your application is not of time or latency sensitive. So if like for example in batch processing applications, if it's using some underlying service, it can continue to retry until it succeeds. So there you can use a technique like retry with exponential backoff. If it immediately fails, you increase the delay exponentially every time until the backend or underlying system service comes back. So this is just an example where like they're just giving an
Hey,
example.
Naga.
Hello.
Uh,
Yes.
oh, okay, sorry. I thought like, oh, you are going to cover a real-time example with that.
Real-time example. I think I'm just going through whatever the material is here.
So I was just wondering if anybody wants to share or use this retry pattern in their project. They want to share some real-world example, or probably if nobody else, I could share a real-world example.
I ha-
Yeah,
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 I
sure.
have one example. Sorry.
Yeah, go ahead.
Yeah. So there was a service which was using which was having queries both on cache and a database. Also, if there is a cache miss, the service requests the database. So,
Mhm.
but there was a situation. Matlab the service was requesting a lot of queries. There was a lot of queries, and we were using a single database for multiple microservices. So when
Mhm.
so there was a point when the microservices was dependent a lot on cache. So matlab, every request was going on the cache, and
Mhm.
it was like 1 lakh queries per minute that was the cache was handling. So we decided that if the cache crashes or something bad happens with the cache, the request will go to the DB, and that will put up a very extra load on the DB, and that
Mhm.
will affect the working of other microservices. So we decided to crash and cancel the retries if the cache crashes. So that was the point where we use the
So,
cancel scenario.
so
So you
basically,
are doing the cancel like assuming
Yeah,
as the backend is busy. Okay.
yeah.
if
So
there's a cache miss,
other
you
microservices
don't.
won't affect it.
So if there's a cache miss, you don't want to redirect to DB. Was that like this?
No, if the cache crashes, because if there is a certain with the increase, a certain increase in the load
Mm-hmm.
on the DB, it will affect the other microservices also. Yeah, but the catch, the main catch here is that the service was not that important, so that we can run, we can still run without the service. That was the main point here, whether not to load the DB with those queries and still go on with the still go on with the service crashed.
Okay, so your scenario was where service crash is okay.
Yeah.
Yeah, so again,
So,
it
matlab
depends
not.
on. Mhm.
Yeah.
Go ahead.
No, no, you were saying.
So I was telling like again, it depends on scenario to scenario. So in your scenario, it works like you can do a cancel and be done. Like you don't want to redirect the load on DB if there's a cache crash. So okay, so got it. So yeah, again, it is subjective to scenario. Yeah, thank you for sharing your scenario. One other example coming to my mind was where think in that way there are one source system which sends data to multiple systems, and then one system talk to, so basically there is source system A which sends data to B and C. B also wants to read some properties of data when it reads to C, but some reason the data never reached to C, and B is not dependent on C. So B will ask, okay, give me additional information, and which C won't provide. So that time B has to retry, and B does not know how long has to retry. So that time it could be that we can add an exponential wait. Okay, try for 5 minutes. Okay, no. Then try for after that. Try for after half an hour. Okay, didn't work. Try after 1 hour. Then 4 hours, 24 hours, and permanently fail. Then does that make sense?
Yes. So that's with yeah, retry with exponential backoff technique.
But
Yeah.
some people, even I have heard, which don't like a retry pattern. They tell it's just a blind shot. So if you see the retry pattern little up,
Mm-hmm. So yeah, I mean like this. Yeah, this retry is basically within just immediately or within some milliseconds it'll retry. And probably they don't retry for forever, right? Like it's just like 2 or 3. They'll normally have how many retry attempts they want to do or not.
so yeah, so I know some people they don't like the retry pattern because it could be like it could fail for, let's say our retry. So the retry pattern should come with some threshold. Okay, I will retry for 3 times and then I
Yes,
will
yes, yes.
set up
Yeah,
a, it could be like a on call alert. If it failed for more than 3 times, it will go to on call or something. But still, people say, okay, what if it failed for 2 times and somehow it passed for the third time? Then, but nobody will investigate why it failed for the first 2 times, and someday it will become a big problem. So there are
yeah,
discussions
yeah,
in
yeah,
between why,
yeah, yeah.
whether we should do a retry in the first place or make it fail request and set up a on call or some kind of alert where people will even look for one single failure rather than it got passed for the third time. So
Yeah,
there are
and
debates and discussions like how we should be approaching the retry mechanism.
yeah, we'll cover that actually. I think likely in issues and considerations and when to use this pattern. I think
Mm-hmm.
there is some points there. We can actually review those points like when you are likely to use this and what are
Sure.
the issues to consider when using
Okay,
this.
I think I jumped really fast. Sorry for
No,
that.
no, no, that's okay. That's okay. I mean, like we will visit that just in a moment. So this is just an example they're showing, like an application invoking a service. The first time it failed, and it just immediately tried after a short interval, and it failed again, and it wait for a little more longer interval, and it succeeds. So, and this is just an example. And let's get into what are all the different issues and considerations that you keep in mind when implementing this retry. So often like you should again like see what your business requirements are and what kind of failures that occur in the systems. So for some applications, as they're saying here, it's better to fail fast rather than retry several times and impact the throughput. So for example, like for web applications, it's likely that latency is important. So if you keep retrying for more number of times, it's going to add more delay. So even if you retry, it's you're going to just use a short delay, and within milliseconds you retry a couple of times. And if it fails, and you can just simply say, please try again later. So you need to have some interaction or message to the user, because it's an interactive application. So whereas like in batch applications, you can increase your retry attempts and even use like an exponentially increasing the delay between the attempts. So that's okay with batch application because there is no user, and it's okay because batch applications tend to take more time. So, and there is another consideration where like if you aggressively retry with minimal delay between the attempts, and most likely this large number of retries, like if multiple clients are doing the same thing, and this retries again could if the service was busy and if all the clients are retrying aggressively, then it's likely that the busy service is going to degrade its performance or even crash. So, and it can also affect the service to become responsive and continuously take more time to process. If a request still fails after a significant number of retries, so it's better to fail that request and trip to use a circuit breaker. We'll get into the circuit breaker, what it is. And you also need to consider whether the operation is idempotent. Um, uh, so that's where like only if the idempotent operations are safe to retry. Otherwise, like otherwise you can have some side effects in the backend. Like there could be some parts like processed and some not in the backend. So you need to make sure that the operations are idempotent. And yeah, so the service can fail for a variety of different exceptions, and you just need to make sure to look at what the exception says and act accordingly. So and yeah, you can actually go through all this considerations. I mean, like in the interest of time, I'm not going to go through all of them. So when to use this pattern? It's basically, as I say, as we were discussing, so it's likely when you know that this is transient false, and if you are like short-lived, so and you know that like when you retry, you are most likely to succeed. That's when you need to try this. So it's not useful when you know that the fault is long-lasting. So because if you keep retrying, you're unnecessarily increasing the load or like the responsiveness of the application. So yeah, so if the service is already busy, then there is no point of retrying. I think they just give an example of C# where they're just retrying until 3 times before failing out. So this is just an example which you can actually go through. And I mean, like if you are already using some frameworks, whether Java or whatever .NET, like libraries such as Resilience or Poly have this patterns inbuilt. Like there are like classes which can help and they can take care for you. So with this, we can wind up this retry pattern. Unless you guys have any questions, I'll switch to circuit breaker.
Naga, one quick question.
Mm-hmm.
So, are there anything for the retries in a distributed way? Like this retry is handling only for one instance of it, right? Are there anything like in a distributed system we have like how to handle this number of retries or overall?
No, I think this is not a single system. So as I mean, like if you take an example here, this hosted service or like the dependent service could be anywhere in your distributed system. It is in the network you are accessing this. So
But if the application is in a distributed system, it could be a client or it could be a service, right?
Yes, correct. It can be a application can itself be a service, another calling service, or it can be an UI. So so depending on like if it's UI or whether it's a service. So I think, but likely the retry, you have to do the retry, right? So,
Yeah.
I mean, like if it can be retried.
So I have an example there. So for us, what happens is we keep a queue in between, and our applications process files. Like there are millions of files which are coming in. An application processing a file, if it fails, it updates a fail count on the queue. I mean, it adds a fail count to that request on the queue, and then it leaves. The next retry is done by any other client, but the fail count is tracked in a separate queue. So it checks for the fail count and it stops after 4 retries. That's, I don't know if that falls into this pattern or not.
That's how
that is actually circuit breaker. So I think maybe we can just open up for questions. I think there is little small variation of how the retry pattern and circuit breaker works, but like both are heavily used in handling the failures. So let's discuss the circuit breaker also, and then have some time for questions.
One question, quick one right here. What is the transient failure? How is that different than other failure?
No, transient can be just like assume that your network somewhere, like it just you often notice sometimes the Wi-Fi disconnects or reboots or like just goes away and comes back, right? So you often notice like as you may be talking to person on telephone, and then the call suddenly drops, and then when you retry again it succeeds. So you connect and again talk. So most of the network failures are like intermittent, like the connection went and came back quickly. So those kind of like connection failures are like transient. But unlikely that if it's gone for a while, like half an hour or 1 hour or more, then it's not transient. Like
okay.
So Naga, in the retry pattern, I get that there should be a threshold, and after a certain amount of threshold, the request that the task is not retried. But
yes.
say, like, how do we handle this failure then? Because now it's truly failed, the task. Now, like, what is the way? I mean, how to convey this message to all the upstream applications? Like, okay, now we tried enough, and what happens at the end? Because there is obviously a human triggering request at the start somewhere, right?
Yeah, so this is often used with circuit breaker. So that's where like which is also good in handling failures. So this is just a retry. Like the circuit breaker actually has some mechanism to report error back to the clients. So even in retry, like after sometimes, like if you know that it's failed, then you need to respond back with an error, right? Depending on how the business what kind of nature of applications. For example, web, you often notice this kind of messages, please try again later, or the So let's understand circuit breaker once, and then we will briefly discuss the questions. And then we also need some time, like there are other 5 other patterns. So we are 30 minutes away now. Okay, let's start the circuit breaker pattern. So retry, as I said, like you retry with the hope that it's likely to succeed. But circuit breaker is kind of a pattern where like you want to fail fast if you know that it's the backend service is likely to reject your request or return failure if you retry again. So that's why this circuit breaker pattern is used. So where like the falls might take variable amount of time, it could be hours or minutes, or like, so depending on what kind of the remote service is and how long it takes to come back to serving back the users. So in a way, like it appears like related to retry pattern, but like there is a little catch. So we know that like we have the transient faults such as this network connections are timeout or being overcommitted or temporarily unavailable. So most of this we can try to use a retry pattern, but as I said, like there can be some unanticipated events and it can take much longer to be fixed on the backend service. It can be complete failure or loss of connectivity for a while, like half an hour or I don't know, it can be minutes or something. So that's where like you tend to use. So they give an example here. Like if you don't handle this, then it might lead to cascading failures. So if there is one service where it's not configured correctly, then it can continue to fail the request, and when it is failing on, if there are so many concurrent requests, then it's most likely exhaust your critical resources like memory, bits or database connections of the service, and it can eventually crash. We need to be careful. And I think this pattern was first brought up or popularized by this guy in this book. So you can take a look at this book later. So if you notice here, like they clearly distinguish the high level idea of circuit breaker pattern with the retry. So retry enables the application to retry in the expectation that it will succeed, but circuit breaker, it kind of prevents an application from performing the operation that's likely to fail. So both like support each other. One, it's retry with the hope that it will succeed, but this is preventing which is likely to fail. So that's where like people generally combine these two patterns. So how a circuit breaker works is basically it has these 3 states called closed, open, and half open. And let's see what these 3 states are. So initially when the circuit breaker is in closed state, that means that the application is behaving normal. So whenever the operation succeeds, it just returns a result. If it fails, then it increments a failure counter. So you'll have some threshold for this failure counter, like if it fails like for 3 times continuously or 5 times or 10 times. So you hit the threshold within certain time. So basically it's not like failing within like 1 hour 3 times. It's not likely to go to open state. So you'll have some time interval, like say within last 10 seconds, if it fails 3 times, then it has reached like a threshold. That limit can be defined, and once this failure counter hits that threshold within certain time, then it goes to open state. So when your circuit breaker is in open state, any request that hit this service is going to be failed immediately without actually hitting the backend service. So and then you will have some timer here. Let's say like it could be 30 seconds or depending on what you configure. So until that time, it's going to reject all the requests that's going to go to the backend service. And once the timeout is reached, then it goes to half open state. So this half open state, you actually track how many success instead of failures like in closed state. So here you just try to see if your backend service is backend up. So whenever requests come here from different clients, so you just try like if it receives like 10 requests, you only try like 1 or 2 of them and see if it succeeds. So if it continuously returns success for 3 or 4, then you know that it's going to that is basically it reached the success threshold count that you defined. If you say that if it continuously succeeds 3 requests, then you will go back to open state. Means that like you behave like as if the backend service is fine, and again you reset this failure counters and keep tracking. I mean, like it will continuously be in closed state until it reaches this failure counter within a threshold. And again, this failure counter is periodically reset depending on what your threshold time is. Like if you are monitoring the failures per minute or per hour or per 10 seconds or 30 seconds, depending on, so every 10 seconds or every that time limit, it keeps resetting and keeps track of its counters. So any questions on this? We will also go back to see like what are all the issues and when to use this pattern.
Is the failure counter for a single request or for all the requests?
No, all the requests. For if one request failed, it's like one failure count increased. So it could be from the same client or it could be from different clients. It doesn't matter. So this is like a global for all the requests.
Thanks.
I think Ganesh raised hand. You have some question?
Yeah. Can you hear me?
Yes.
Yeah. So can you explain a little bit more about that cascading problem with this one? I was reading about it on some articles, but I couldn't get it. A service A calling B and then the B fails, something like that. Can you give some example like that?
It's basically the cascading how it occurs is like I don't know if there is a good diagram here. No, I don't think so. So the cascading problem occurs like say that you don't have this issue at all. I mean, like you are not using the circuit breaker, assuming that, just assume that. So what happens normally, like all the requests behave as if they're in closed state, right? You don't track anything, so you keep hitting the backend service. So the backend service, I mean, like you don't know when it's returning failures for what reason it is returning the failures. It so happened that the backend is returning you 429 error, like too many requests that indicates, but you still keep retrying. Like if you are continuously, you don't have any circuit breaker, so you keep retrying, and the backend service, its resources is likely to exhaust, right? Like if you take about connection pools, it would have already exhausted the maximum connection pools. If it has like 100 connections limit, like then all the connections are already being used by other clients or other requests.
Yes.
That's where it's returning you 429. So the calling applications keep retrying, and it will also have its own resources maintain, like the connections, it will keep retrying. So like if imagine you have some certain number of requests. Let me see if there is some whiteboard. So for the calling application also will continue to exhaust its resources because it's keeping so many number of open connections to this particular backend service. And over the period, it may happen that the calling service also may be exhausted of the services, and the chain can continue, right? Not just for one calling service, it could be for multiple calling service. If the backend service is so critical that like multiple calling services are using that, and if all of them are waiting on that specific service, keeping the connections open or like some other resources open, then like most of the services which are dependent on the backend service is also likely to fail. I don't know if I made it right. Like I can switch to whiteboard to explain otherwise.
Okay, yeah, thanks for the detail.
Yeah, I think Raghav, if you can take some example on a whiteboard, a simple example, or I can try helping out some example.
I wanted to see if there is a virtual whiteboard. Let me see.
So I just want to see if somewhere if I have to implement circuit breaker, what could be like a very simple scenario could you be using?
I think his question was not on exactly circuit breaker, but like the problem of cascading failures, right?
Yes, yeah.
So I mean, like it's basically whatever I said, right? Like you have one dependent service. I don't know. Can you see this?
It's little blur, but we can see some box. Yeah.
I don't know.
Oh, did you turn on the video by any chance?
Yeah. Right.
The video, but I think sharing it still.
I don't know if it's visible.
It's better now.
Okay. So if this is a backend service, let's take this as backend service, and let's assume you have this calling client 1, and let's take another client 2. So what happens is like when a calling application, that you can assume like some UIs are here, like there could be some clients for this client itself. So this service can talk to this service basically for some service, right? Like it's calling some web service or something or HTTP. So assume that like this has some connection pool, which already, let's assume like 100 connections. It's already the maximum limit. It's reached, and this is service is busy. So, and whatever the request that's coming from the client, this is also keeping in memory. So whatever the state of the current request, so all the request it's keeping in memory, and it's basically calling whatever the backend service it wants to, and then like only when this succeeds, then this can remove or exhaust or like clear up these resources and return success. But like if the service itself is very busy and not able to handle any of the requests from this client or this client, so all these services which are dependent on this, then it's going to fail, right? Like imagine if there is another service which is dependent on this. So this is dependent on this. So because it's not returning any request and it's continuously failing, and this service also is not failing and waiting continuously for this, it will keep on adding its open request. The open request will keep increasing. So this will keep increasing, and resources also likely to exceed. So if this also trips, like this also fails, eventually exhausting its own resources. So if there's another client P which is dependent on this service, client 2, then it's also going to face these issues, right? Like if this starts to become unresponsive, so this is also going to hold on its resources, whatever it has, till this actually returns a success response to this. So the idea of circuit breaker is, if you know that this is not responding correctly, or like this is unlikely to succeed, so you fail immediately. You don't hold the resources for so long, and you fail this service immediately, so that like this can continue to serve other requests.
Okay.
So I mean, like that's where like the cascading problem could come in. If you imagine like the system of Netflix or other systems, like they can have thousands of microservices where this kind of dependencies and all are like very I mean, like you can't even imagine like that kind of dependencies they'll have. So that's where like having a circuit breaker always is a key. That like you are failing immediately and not exhausting resources, and be ready to serve at least some other request.
So if the backend service fails, so then here in this case, the client one can decide to return either a failure or success to the client 3 if it can handle that failure gracefully.
Yeah,
right?
correct.
Okay.
It's like fail fast rather than, yeah, that's the idea. If you know that you're going to fail, so fail fast, or like use some exponential backoff and try after some time. If you're using retry with exponential backoff 2-3 times, if it's okay only. Everything depends on what your business scenario is, and whether you want the immediate response, or like you are okay to respond after some time. Depending on that only, different techniques can be used.
Okay. And I also heard about like there is some Netflix library that that is for this pattern. Are there similar solutions in other languages like C# and all? Like any idea on that?
Yes. I think we'll also look at the sample code here. I think the link that I'm showing right now, we have also an example of the circuit breaker.
Yeah, I think specific library is the Poly, right, Naga?
Poly or Resilience 4J, those two are like the popular ones. I think there are many others, like most
Netflix is the Hystrix.
Yeah, Netflix has Hystrix, I think.
Hystrix.
.NET is Poly.
Yeah. So yeah, most popular frameworks have this already implemented. So you just need to know which library or like package to use.
Okay, interesting. Thank you.
Okay, no problem. So let me.
In the closed state right here, right? I see we only increment the failure count. When would we decrement the failure count?
No, there is no decrement of failure count. So it's basically this failure count is for certain time period, right? Say you want to take the circuit breaker only if you receive like failures within the last 30 seconds. So after every 30 seconds, this failure counter is going to get reset to 0 and then start incrementing again.
Is it like a sliding window, or like, you know, right after 10, you know, that 10 seconds they're gonna reset it?
Yes, kind of, yeah. So after that time period, it's going to reset and then continue to have, you can imagine like a sliding window. So you just make sure that for the last 30 seconds, you'll have this failure count.
Okay, so that's where the decrement the failure count, which is not decrement completely.
Yeah,
I mean,
it's not
set to
decrement.
0.
Yeah, correct. Reset to 0. Yeah.
I think it does a half open, right, Naga, to see like if it succeeds and then closes the circuit.
Yeah. So first, it's in closed state. Closed state means like it's behaving like normally, right? So whenever you succeed, it's going to return the result. Otherwise, it's going to increment the failure. Say that like this failure was like once an hour, like but your threshold is like key failures within the last 10 seconds or something. So then this failure counter is going to reset after every 10 seconds. Even if it fails every 1 minute, your circuit breaker is not going to go to open, because it's just having an occasional failures, which may be even legit failures. So
okay, yeah, it makes sense. From close to open, it does like that.
Yeah, correct. So this is based on like if it reaches the threshold that you define for a certain time limit, only then it goes to open. In the open, it'll have some timeout. It will just wait for 1 minute, or I mean, like depends on your configuration, how long you want to wait before going to half open state. When it's in open state, it's going to reject all the requests that's going to come. So that's where like most likely this may be for a short period, but like it depends. It can also increase if this loop is continuously coming over and over again. This timeout could increase. There could be some settings for that also.
Yeah.
So only when it comes to half open, it just tries some request. If all of them succeed, then it's going to go back to closed state.
Makes sense. Yeah, thank you.
And then let's look at some of the considerations that you need to make. So you need to be like you need to check what kind of exceptions your backend service is returning. Like most of the times, like the type of exception that's returned by the backend might have some information. So depending on that, you can decide whether you want to circuit breaker or not. So and yeah, it's mostly like protecting the backend systems. That's where this needs to be used. There is some considerations again, like you can have a periodical leaping the remote service to see whether it's going to become available again. That ping can help to switch to half open state. That can be one consideration instead of just having a timeout. And there is another like accelerated circuit breaking, where if instead of hitting the failure limits, like instead of hitting the 3 failures within certain time, or 10 failures, or depending on whatever limit, if it returns 429, it means that it's already saying I'm already overloaded, either because the service is unavailable, or the client would have hit rate limiting, throttling limits. So in those cases, even if you wait for subsequent failure limits to reach, it's all the subsequent requests also is going to return 429. To basically speed up the circuit breaking, and as soon as you notice this kind of 429 errors, you immediately go to open state. And when you use this pattern, it's basically you are trying to prevent the application to overload the backend service, which is likely to fail this request. So it's kind of mostly safeguarding your resources and preventing them from crashing. So it is not recommended if you are using this to control your local resources instead of in distributed backend services. So it's not recommended for your local in-memory resources protection. There will be an overhead. So this is just here is an example they have given in C#. I think like even for Java folks, it may be mostly similar. You just have reset, tip, half open, whether it's in closed state. This is just an interface stating different states. And this is an sample implementation. I think if it's open, so this is most likely going to throw an error. If it's closed, it's going to serve the customers, serve the calling services. Whenever some exception, it's going to trip the circuit breaker. So let's look at more. So when it is open, it's also checking here. I think you can go through these examples later. They have clearly highlighted the key points apart from the actual code. It actually have given like when you reset the state and when you switch to half open and when you so you can actually go through this link later. So in the interest of time, I'll go a little fast.
So Naga, what would be your suggestion? Should we implement this circuit breaker pattern and write the code as shown ourselves, or use the libraries and other frameworks for it?
Yeah, even if you use a library, you need to manage this state, and you need to manage the configuration, and you need to control this flow, right? You decide when it goes from open to half, close to half open, or like close to open and open to half open. So here, if it's open, you know that it's going to fail all the requests. In the open, we check whether the timeout is exhausted, or if you are using some ping mechanism to check the backend is service is up, depending on whatever the logic that you are using. So then you switch to half open. So when it's in half open, then you try at least some of the requests, see if they succeed or not. I don't know where they have given that specific example.
Naga, I think actually I've used Poly. So if you use Poly, it becomes very simple. You don't do a lot of this implementation. All of this is like configurable, like aspect oriented. So
okay,
it becomes very straightforward. Like in Hystrix, Java, same, right? You don't do a lot of implementation. You just add those details. Like
okay. Yeah, I think depends on the library. I think they abstract a lot of implementation details.
Yeah.
So it may be just a configuration and setting up which classes and which method you need to trip.
Right.
Or, yeah.
It's pretty straightforward. If you see Poly example, you can see like how that is done.
Yeah.
I don't know if anybody would implement all these things, because
I think they may have given here for understanding better. Yeah, I think that could be the reason. Any questions before we go to the other patterns? Rajat raised his hand. Rajat?
Yeah. So I was asking how would we implement it in a distributed transaction session, distributed transaction system. So,
Distributed
if
transaction is a different concept. So I would say distributed. If you are using distributed transaction, then it abstracts all of these problems, right? Like it even if one of the system in distributed transaction system fails, because you have the transaction spanning across multiple systems. I don't know who is having this. There is some disturbance. Okay, so in a distributed transaction, if you are using distributed transactions, it's altogether a different concept, right? So you don't need any circuit breakers there, I think, because if one of the system is fails, the distributed transaction concept itself takes care of rolling back in all of the other systems. So, but I think it may if you want to have some flexibility, I think this is more of useful in eventually consistent systems. That's what I assume, but like I don't know how it makes sense, because in distributed systems, if you are always using distributed transaction, then depending on the failures of one or more, there you have that coordinator and other stuff which is already taking care of all of this. I think they might internally use the circuit breaker concepts to fail fast. So You don't need to explicitly use this. That's what I feel. Maybe others can add in, but that's what I'm assuming. So
I think like the example was exactly right. They use a common queue to handle all these errors, number of error count. So that's how I think the question is more about like if the application is distributed, right?
mhm,
So you have if suppose you have this API which is calling the backend, and this
mhm.
application is a distributed one, so it's on couple of pods. It's not like a single instance, right? You have multiple instance of this API, and now if you're counting the errors, should we count the errors happening on all the instances or only on one instance? Does it handle like one instance errors, or does it also handle errors happening on all the instances, right?
No, I think we need to track at instance level because for a service like I think you will understand that when we go to the bulkhead pattern. So we need to track these errors at instance level because the other instances can be free and they can be serving customers. One instance could be overloaded, so that's it could return those kind of 429 errors. So it depends on the type of error. That's what I think. So if it's kind of just overloading of one instance like 429 and other instances are available to handle request, so those kind of errors you can have at instance level. I don't know if there is any type of error where you need to be worried about all type of instances.
Yeah, I mean, like if there is multiple requests to handle, right, and all the instances are hitting the same backend,
Okay,
then
that's a good example. If
yeah,
if all of the instances are actually going and using the same, and I think in those in that particular situations, the instances itself have some kind of circuit breaker, right? If the backend is busy,
mm,
they themselves know that they don't want to hit that and fail immediately, or just return the failure or to try after some time.
yeah, yeah. But again, now the number of errors that we want to um, break the circuit for is
Hmm.
like kind of distributed, right? If it was a single instance, we would say like, oh, once I hit five errors,
Hmm.
then I say like I'll close the circuit. But now if I have like five instances running, then each one should be like one each, or how do we handle that? Is I think
I
from
think
what
it's
I
mostly per
remember,
instance. That's what I think. So
yeah, I believe some of these libraries also handle those cases. I don't remember
mhm,
exactly, but
mhm.
history and these handle those also. Like it handles
Yeah, they should
all it.
have. I
Yeah.
think those settings can be configurable, and I think there could be also depending on what kind of exceptions you want to and categorize for counting the failures. I think even those can be configured. I think
Mhm.
so. I think the other guy's question was more on distributed transactions, so that's a different concept, right?
Oh, is it okay?
Yeah, I mean, like in general, distributed systems means like most systems won't use distributed transactions. So whenever there is a distributed transaction is used, then that application is of strong consistency nature. So in those strong consistency nature, so either all fail or I mean, like either all of them succeed or none of them succeed, right? So that's a transaction concept. Um, So I'm thinking that's indirectly handling most of these failure scenarios if you use the transactions.
Mhm.
But again, it depends on like whether you have distributed transactions along with some other non, along with some eventually consistent systems.
But I remember when we had that distributed transaction session,
Hmm.
you mentioned there like if the it first of all asks all the services to prepare, and if they say okay they are ready for the committing the transaction, and then it
Yes,
gives them
yes,
okay now commit. If
yes,
some of them fails, the
yes.
coordinator keeps the note of them and keeps trying indefinitely, like because there is no
Yeah, correct,
no
correct. So
rolling back from now on.
Yeah, that's different from the circuit breaker, but like that's the responsibility of the coordinator in a distributed transaction system. So once all of the nodes commit, then they need to like say when they respond with prepare yes, then cannot reject the commit later. So that's the abstraction of the distributed transactions, right? Like, and that's a responsibility of coordinator to indefinitely try, and that is not similar to the circuit breaker because there the prepare yes commit. I mean, like when they agree to commit in the prepare phase, they have to commit later at any point, even if they crash for 1 day or 2 days. Okay, I think we are spending more time here, so let's switch to other patterns. I think we just completed 2. We are almost over an hour. So the next one that I'm going to discuss is a bulkhead pattern. So this is basically kind of pattern where like you isolate or segregate your application into several different categories or services or some. I mean, like you basically isolate some set of resources into a single some category of services. It's if you want to compare an analogy, I think they have given an example of a ship where like if the hull of ship is compromised, only the damaged section fills with water, and instead of the whole ship sinking, it just only the damaged part is filled with water. So as an analogy, like if you have a single consumer calling many services, let me just show a diagram. Diagram is better than this. So here you just look at an example of there are 2 kind of workloads in an application, and one kind of workload uses a backend service A, and the other kind of workload uses the services B and C. So imagine if something happens wrong with service A, and since you isolated this flow, this workload flow, one flow with the rest of the application. So even if something fails, only this path is going to fail and not able to serve customers. But the other part of the workload 2 category, like you continue to serve customers in those service B and C flows, whatever the capabilities that B and C offers, you can continue to serve. So this is just one kind of an example where you have multiple backend services, and so one of the flow failed, either maybe it exhausted or it completely crashed. So you're just making sure that the remaining part of the application is at least able to continue. If you mix up everything and you have a common flow to handle all of those, a common intermediate pool or something, then it's going to fail the entire application. So that's not recommended. So this is just another example where you have multiple clients. Here a single client is actually initiating multiple workloads. Here you have multiple clients invoking the same service. So here like one specific instance got failed because it got too many requests, and this client would have initiated, since this client is talking to a specific instance and he's sending large number of requests and overloaded this might have failed. But other clients are able to still invoke other instances of the services and still receive the service. So some of the considerations, so you need to define this kind of partitions considering your business and technical requirements. So you need to consider the isolation, considering all the underlying cost, performance, and how you want to manage these resources. So it's often this pattern is combined with retry, circuit breaker, and throttling patterns. So which is a rate limiting. Again, when partitioning the consumers into bulkheads, you can consider using the process thread pools or semaphores to kind of manage those shared overhead. So when you are partitioning into bulkheads, you know that like they can be deployed into separate virtual machines. So you can use separate Docker containers for each of them, so that like even if one fails, the other continue to succeed. Yes, so we need to use this pattern to isolate the resources to consume a set of backend services which fall into certain domain in your application or certain category. So maybe as an example, you can isolate all the critical piece of backend services into one category and non-critical into another category, so that like even if non-critical fails, you can continue to serve critical. So this way of isolation also helps application to protect from cascading failures. It's not useful when you want like less efficient use of resources which are not acceptable in the project. So if you isolate this kind of way, I mean, like there could be some resources which are not much efficiently used. I think they have given an example of the way you use Kubernetes pods to spin different services with their own CPUs and memory limits. I think I went a little fast in this pattern. Any question on this?
So Naga, I'm sorry if this question is silly, but I never worked with this microservices kind of a world. But let's assume somebody has a task to write an equivalent of a database. Would you be using all these technologies that we just discussed?
What are you saying? Writing a database, you mean?
Not exactly a database, but I just gave an example. Let's say somebody is given to write a piece of software like a database or a stream processor or something which processes a lot of data, and so in that case should we be using these patterns or not?
Yeah, I mean, like these patterns are there, like as you know, like the patterns are some of the best practices for certain problem, right? Only if you want your business to behave or like um, you want your system to be more resilient, that's where like you more think about this patterns. But I know for sure like most of the systems might not consider all of the patterns. So you choose which patterns to use depending on your application nature and what kind of guarantees or SLAs you have with your clients. It all is driven by that, right? Like if you very have mm, like if you always need to guarantee some SLAs like 4 nines of availability or 3 nines of availability, depending on those availabilities you have certain downtime permitted per year. Like the 4 nines of durability means like maybe 3 days of downtime may be okay for your application. But if you say 5 nines of availability, then you only have few minutes per year or like seconds per week of downtime permitted. In those cases, you need uh, more resilient system, high resilient system. So that's where you're likely to use uh, most of these patterns to isolate the failures and handle or recover quickly. So it's just that like you decide when to use which pattern, and As you can see, there are tons of patterns here. Each pattern focuses on a certain problem. So it's just a recommended best practice. So if your application nature is different, then you can fine tune or have your own pattern built.
Yeah, I'm not clear on this bulkhead pattern. Could you give an example where, bulkhead pattern not being used, and then when we applied it and it's helpful?
As I said, like it's basically this is kind of prevents in cascading failures. So, for example, if there are like this service dependency is the one. I don't know how to explain. Like you can assume like there are some certain piece of services where you have which are critical to your business, and you don't want them to fail. Um, so what you can actually do for the critical services, you can isolate the way which is done in this example here. Just like you can isolate that workflow from the rest of the workflows. And even after isolating that specific service, you can also have tons of service instances which are serving the customers. So if some service instance is failed, so in this case, this service instance is failed, then you know that like you have one less service instance from the, if you have always to have the available, and then if one of them fails or like too overloaded, you can at least have a load balance mechanism to redirect to other clients, other service instances, or you can also have another service instance added if you are getting many requests. So you can, so if you,
so yeah, in that case, is that like, can you scroll down a little bit? In that case, the way it looked right now and the way you describe it looked to me like horizontal scale, right? But based on the diagram, it seemed like it not really have a load balance, right?
No, I'm just talking like, so the idea of bulkhead is just to isolate the client's behavior from other clients. So in this example, if one client is simply spending too many requests, and if you have a pattern that like all the requests of client one, you are redirecting to a specific service instance. So the specific client, because of their abrupt behavior or too many requests, you basically you overloaded one of the service instance, but you have the other service instances up and running. Your system as a whole is still available to serve the clients. So if there is another client which is coming, so they can be redirected to the service instance or the service instance. So it's just a way of example of isolating your resources. Here, like it's just shown as an example that like each service service B may be serving certain functionalities, and service C may be serving some certain specific functionalities which are still available, though the service A functionalities in the application are not available at the moment. So it's just this pattern gives us an ability that can continue to serve customers at least for some part of the functionality of your application, though certain parts of application can tend to fail with um, for some time. So again, like don't see each pattern as their own individual patterns. So most likely this pattern is going to be combined with circuit breaker, retries, and rate limiting, because each client will have certain limits, like he cannot send more than 100 requests per second. So that's also to safeguard your resources.
So Naga, I feel like this is in line with the database sharding. So yes, suppose you don't want to, some of the requests are causing issues in the database. Then you partition the database in such a way that it's not becoming hot there. So that's what I feel like. It's very similar
Yes,
to that.
yes. Yeah, I mean, like it's kind of way rather than sharding, it can be, I think, more of tied to federation. So it's a similar
Yeah,
concept where you categorize based on functionality.
right,
So, yeah.
right.
Is it based on functionality or is it based on sharding, right? Because it's two different things, right?
Yeah, I think it's both. I mean, like this concept can be applied to both, right? Like here, this is kind of based on if you look at database federation, like each part of database is handling like certain specific tables or like functionality for certain tables, right? But the second example, it's the same service, but you have multiple instances. But the pattern, like the way that you see here, one client is always talking to one service instance. So if this client is behaving intentionally, he wants to bring down the service, or he's sending too many requests that this service specific instance is not able to handle, then only this instance is being failed, right? Like imagine if the same client is talking to all the instances, you didn't isolate one client to one specific instance. So this client can bring down all the service instances, right?
Okay. Though the functionality within the service instance is all same. So here.
Yes, yes. So it's basically you are isolating the problem to one specific instance or one specific service. So depending on what it is. So that's the idea of bulkhead. So you're isolating the failures to as small part of your application as possible.
But
So I have one question here. So how do you do dynamically in real world? Suppose I know there is one client which is is doing this DDoS attack or something like that. So how do I do that? Like I observe it and then put some kind of rules on the instances that if it's the request comes from this particular client, just go route to this instance. How do I do it in real world?
Yeah. So the DDoS attack and all can be prevented using throttling pattern. So throttling is a rate limiting where you set on API gateways or I think load balancers also might have, I don't know. Most likely API gateways have this. So where they notice like in the API gateway that you have to know the client ID, right, to invoke the service. So based on that client, you can actually set some limits like I allow like 100 requests per second or 1000 requests per second or like 10,000 requests per second. So depending on your limits and capability of your backends. So you can set those limits, and this pattern can help in DDoS. I think this is just the idea of this pattern is basically isolating the parts of your application, which means that it can be the services or service instances. You want to isolate the failures to as small part as possible, so that like the rest of this application can continue to be up and running.
But by doing this, are we not going against like high availability?
Yeah, that's what I think.
No, it's actually, in fact, supporting the availability, right? If you see, this client could have brought down the other instances also of service A, resulting in the total service A failure.
Suppose like client one, sorry, client one needs this service, like it's making like thousands of requests. Client two and client three are idle. But now that we have allocated service instance, client one to a specific service instance, the service instance of client 2 and service instance of client 3 are available, we are overloading the service instance 1 of client 1 and will start failing, right? We could have served the client 1 with service instance 2 and 3.
Yes, I agree. So I mean, like if that is something which is possible, I mean, like you can do that. I think here in this example, they just want to illustrate that the failures you want to restrict to one specific instance or one specific service. If you know that the failure is going to occur for sure, you don't want the whole service to fail. You just want at least one instance to be failed, right? So I think the example you gave also makes sense, where you can distribute the load to if service instance 2 or 3 to be able to serve. That could have been possible. But I think here they just wanted to demonstrate that so if this guy is like maybe an abusive client, his intention is only to bring down service, or I don't know, it could be he's simply having too many requests to be pinned. So if you would have allowed all other the client to access all the other service instances, there is a chance that it can bring down all the whole system also. Again, a trade-off, right? What you want or not.
Yeah, you're right. I think it's trade-off. What trade-off you want to pick with this?
Yes.
So, Naga, one question here. So this assumes that we stateful application, right? Because in stateless application, the same client won't be going to the same instance, right?
Yeah, correct. So yeah, that's also correct. So yeah, the reason where like you use same client going to the same service instance is most likely where you have this client state is preserved in this service instance. But like if you in this example, like all instances will have access to the same state because they belong to the same service. Yeah, but it can be that can be one example, but like
I think WhatsApp does in that way. They keep particular users in one instance and the other set of users in other. So your request will go to your dedicated instance.
Then that becomes sharding kind of way.
Yeah, so I think that's more of, again, those instances also needs to have some replicas, right? So it's again, I think this is not talking about database. I think it's mostly talking about service instances.
No, even I think WhatsApp is doing like your request is go to specific service instance. So it's not like it is going to specific database. So there will be a particular service instance which will handle your requests.
Okay.
That's what I have read, like the WhatsApp architecture.
So yeah, the bulkhead pattern is also applicable to like local services. Like I know we are talking about like one of the questions someone asked was, how do you do this in a stateless application? So it does not even have to be distributed. Like let's say you have a service which offers 3 APIs. Let's say create user, update user, and get user details. Now for some reason, and let's say it's a Spring Web application, and you have 20 server threads. Now let's say your create user is for some reason taking a lot of time, and if you so if more create user calls start coming, then it will block all the 20 threads. So here is where the bulkhead pattern comes in to help. You do not allow all 20 threads to be dedicated to one API. You divide it like, let's say 10 20 or something like that. So that is one of where you can even apply it in a in a stateless service also.
Okay. Yeah, again, most of these patterns are often combined with other patterns, which there are many to actually look into. I think the more patterns we look, I think the more better we know which kind of patterns can be combined and when this can be used.
Yeah, I think again, it's like you said, it's trade-off of like what you want to pick one over the other, right?
Yes, yes.
Your requirement, yeah.
So you know, I'm thinking the first two pattern, the retry and the circuit breaker, was put the responsibility to the client side, and this Bulkhead design pattern would put on the responsibility on the server side. Is that fair to say?
It's on the not just the server, it's the way you design your application and partition the workflows. Or like kind of you isolate some parts of application. The fact that like you are deploying each of the services on different virtual machines or different like you are giving a part of service or application certain responsibility from the rest of the application. You are isolating into bulkheads with the hope that like if something happens with this, the rest of application is good and still available to serve the customers.
Yeah, but I mean, like for this Bulkhead pattern, the implementation have to be on the server side. The client side, they cannot do anything. They're not doing, right? The server side will decide where the request going to and how to isolate that.
I think even the first two patterns, it's not necessarily client side, right? If your service is actually calling,
your server side needs to handle the circuit. I mean, like each service needs to have its own kind of retry or circuit breaker mechanism.
Yeah,
I mean, like,
but I'm thinking in terms of the caller, the caller and calling. Yeah. So
correct,
the
correct.
retry have to be on the caller side.
Caller, yes. Okay. So I think if there are no further questions, can we look at one other pattern or should we call it a day? Maybe we can just quickly look at other pattern, right?
Like time check, we are at 10:36. So
about one more, or like should we call it a day?
So how many more? Let me go back to your session and let me see.
We have at least like compensating pattern, queue based, and leader election and health endpoint. We can actually pick that in a another session if that is fine.
You can split that, and then have the next session.
Okay. Every time I think I can cover all this quickly. Now we only like went.
Is the next pattern you intend to talk, is it closely related to the three pattern?
Not really, but like at least maybe we can just cover one, at least easier one. Let's see. Let's cover at least the queue-based level load leveling pattern. This is basically you use a queue to smoothen the load. Like if at times you can have like peak loads coming in, and sometimes you may have less load. So in the peak load, it may happen that your services are not like they don't have enough resources to handle those. So in those scenarios, like what you can actually do is you can actually add a queue in between before your service. So all the calling applications or tasks, like they can put messages into the queue, and as you can see, it has like variable loads of the request from each of the client. Okay, I want to mute someone. So this, so you add a message queue, and the service, depending on its capability or like depending on how many requests it can process, it can continue to pull the messages from the queue and process in its own pace. So it just gives an ability, like at times you have peak loads, and if they were directly calling these services, it may not be able to serve all those many requests at one time. So you add a queue to level the load. So this can help maximize availabilities, and you can also it can also help with scaling, and it can also help control the costs. But you just need to make sure that, like, the fact that when you add this message queues, it becomes async, which is like one-way communication. But if you have a requirement that you need immediate response from the backend application, then or like with low latency, then this might not be the best to use. So it's useful to any application that are subject to, you use this pattern only when you know that there could be a certain times where you want to handle the peak loads or overloading, but rest of the times the load is under certain limits. This is just an example. Like if it was if there was an web app which is directly talking to the data store, and if they're directly talking to the data store, then you know that, like, it can depending on the number of open connections, or like it can handle certain number of requests and it can time out on others. So just you can refactor such an application by adding a queue, and this function app is basically kind of a lambda which just simply picks up messages from the queue and updates the database in its own place. So, and this can be triggered whenever some messages are placed into the queue. So it's just a sample way of here you are just experiencing certain timeouts or failures, but like whereas here it scales with load. Any questions on this?
If we need a response, then we need another outgoing queue.
Yeah, if you need immediate response, then these queues are not right, like, because they are async. They are more of guaranteeing reliability, and it offers scalability. But like this is not useful if you are expecting with minimal latency. In that cases, you look at other patterns to increase your backend service instances, and also have some load balancing mechanism instead of queue to see. You can have more service instances, so accordingly your costs also will vary, because the moment you are adding more service instances to handle the more load, um, um, so, and also some kind of load balancing and or some other mechanisms to handle that load or distribute that load, so your cost is going to increase if you compare the same approach with using a message queue. It's again a trade-off whether you want an immediate response. If that is critical, then you don't use this pattern and directly go to other patterns.
Okay, so what if we need like asynchronous response, then we need another outgoing queue.
Yeah, async response is as simple in this case as if you just place a message into the queue successfully, it means that your task is done. So whatever you need to trust whatever the backend system which is handling the messages from the queue does its job fairly, correctly, to ensure that the system will eventually go to a consistent state.
Okay.
Again, most of these patterns are like designed around eventual consistency, right? So, any other questions?
Would it advisable, like, let's say I want to call the RPC, right? But they block before put the message to the queue, right? So the message going to the queue and get processed, and I'm waiting. I have another outgoing queue, and then when it responds, I can correlate the request and the response, and then send it back to the caller.
Are you saying like using RPC and queues together?
Yeah, right.
Okay, you are just using RPC just to place messages into the queue, you mean? Or?
Right, yeah. So I put the kind of like another service in front of the, right there, right? So all the request message are gonna go to the queue, and then I have another queue for the response. When they go back,
okay. Yeah, so there is some request queue and response queue. Yeah, that is possible actually. So what you can actually do in that case, you just place a message here and you wait for another response queue here, where this app can actually place as soon as it process, it can put response in the response queue, and this service instances can wait for the queue to arrive. But when you add that kind of a workflow, you are waiting for this message to be picked by this function app, and then it's going to put the message response message back into the response queue. So this is going to add a significant delay unless you have many instances instantly processing and immediately updating back.
Right.
So
that would help me to handle the RPC as well, right?
Yeah, correct. I mean, like if you are looking for certain kind of response with some good some good latency, I mean, like not good when I say if you are okay to wait for response from the queue instead of just immediately within some milliseconds, then you can use that kind of a pattern. Most likely that's what is going to happen, right? Even if you don't have a response queue, you generally design some other read-only flows where you have some other mechanisms to read the data from data store directly.
Yeah, but that way I cannot correlate my request to my response.
Yeah, if you need that kind of a capability to relate request and response, if it's a request response kind of pattern of an application, then you can have, as you said, the response queue also.
Yeah.
But the fact that you are adding message to the queue, it can take certain amount of time for the application which is processing the messages from the queue, and the time it processes and the time it puts to the response queue, and the time it's going to receive. So if you are okay with that kind of pattern, then yeah, you can use two kind of queues.
So Naga, what is mean by a service bus queue? I mean, are they using here a database kind of a queue, or this is like just a data structure queue?
I think it's just a queue. I mean, like you can just literally assume like a queue, maybe like first in, first out, or just a simple queue, simple distributed queue. So the idea, I think here in the example, they're just, it's basically used to queue up the load depending how many of our service instances you have. The idea of this pattern is instead of the instances directly talking to the data store and some request failing because of certain peak load, you will have the queue to smoothen or like the level the load, and you have an application which is processing the entries and inserting into the data store. You have more reliable and more available or scalable application here, which can handle spikes and peaks, than this kind of an application which directly talks to the database.
But then are we not missing an ordering here? Because naturally, if everyone talks to the data store, we get, because data store gives us
Yeah.
a consistency,
So
right? It gives a strong thing. It knows what happened before, what happened after. But once we put in a queue, we are taking everything into our own hands, and now we need to
yeah.
make
So if
sure.
you use, so when you're talking about ordering, there are multiple ways of ordering. I mean, like casual ordering is basically kind of halfway, not like very strict sequential order. but it still makes sure that the requests which are received now and after some time are placed definitely behind. If you want a strict order, you can use a FIFO queue kind of implementations, first in, first out queue. So, but you just need to make sure that they're a little costlier than normal queues. So, yeah, if you can still make sure that this is a FIFO queue if you want to ensure that ordering. But like mostly you assume that you need, but like you may not need in most scenarios. But there are some scenarios which definitely need FIFO ordering. In those cases, it makes sense to use a FIFO queue and still have this pattern used.
And with this pattern, the transaction is out of the window, right?
Yeah, it's not a transaction. It's just um, a regular distributed system without transaction right now. Yeah.
Yeah, I think this pattern have nothing related to transaction.
Yeah, it's just to level the load, just to handle some occasional peaks that you normally have, where you don't want your data store to just for this. Imagine like in a day, in 24 hours, there could be like 1 or 2 hours where you experience this load. And then you don't want your database to double its capacity just to handle this load. So otherwise you are wasting its connection or connection limits or the resource pool which is intended to serve um, regular load. So just to smoothen those kind of applications, you can use a queue, and this function app can know the database limits and continues to process in the same uh, like as you can see in this picture. If the traffic is variable, but like the way the service is handling is based in a constant rate, consistent rate. Any questions? Otherwise, we can wind up the session and we can discuss what we can do for next week. Okay, I'll stop recording. Just give me a minute. Thank you, everyone. Stop recording.